All right, so we're going to be picking up where we kind of left off from our last lesson, which was giving you guys a little bit of an introduction to these trig ratios and kind of how to set up sine, cosine, and tangent. Okay, can someone remind me really quick, what was that little phrase that we had that we can use to help us remember how to set up sine, cosine, tangent? Good, SOHCAHTOA. So I'm just going to go ahead and write that at the top of my screen here so that we can kind of reference back to that. Okay, what we're going to do today is start to solve for missing side lengths on triangles using our trig functions. Okay, so you'll want to make sure that you have a calculator with you because we will be doing some of the sine, cosine, and tangent. So if you didn't grab a calculator, you're going to want to go get one or get yours out. Okay, so we're going to still be setting up these trig functions like we were doing on the other day, like even on the front side of this page here. But what we're going to see now is that one of the sides is going to have a variable next to it, and that's what they're going to want us to solve for. And so in order to solve for a missing side, we're going to have to figure out exactly what trig function it is that they want us to be using, and then how to set it up as like an equation and then solve for that missing piece. Okay, so we're going to get into some examples today so you can kind of see how this works and kind of how we're going to use this. So this first one here, let's read it here, and it says a certain city code states that the base of any handicap ramp must extend at least 15 feet from the entrance of the building with an angle of incline of no more than 5 degrees. If you were to design a ramp meeting these minimum specifications, how high off the ground would it rise to the nearest inch? In a problem like this, where it's like a story problem, like a word problem here, it might be helpful if we draw a picture. So I'm going to start out. I know that we're dealing with a right triangle, okay, because that's what we've been working with when we're doing like our sine, cosine, and tangent, okay? So I'm going to draw myself a right triangle here to kind of symbolize what this ramp would look like. This is where my right angle would be. So let's go ahead and label our sides appropriately here, okay? So it says that the base of any handicap ramp must extend at least 15 feet from the entrance of the building. So if we think about where the entrance of the building would be, it'd be on that upright side, like the far right side of my triangle here. Now, if they're talking about the base of the ramp, they're talking about the other straight side, not the hypotenuse of this triangle. So the 15 feet would be down here. Then it also says that the incline can be no more than 5 degrees, okay? So the 5 degrees would be this angle of incline. So how much like the ramp is going up at an angle of. So that would be this angle down here. They're going to say would be 5 degrees. Okay, they want to know how high off the ground would it rise to the nearest inch. So the rise would be that other leg that makes the 90-degree angle. And so I'm going to just put an X right there because that's going to be the side that we're trying to figure out. That would be representing how tall this ramp is. All right, so let's think about how we would set this up. Now, when we set up sine, cosine, and tangent, we don't ever use the right angle to help us do that. Okay, it doesn't quite work if we're trying to use the right angle to set up sine, cosine, or tangent. We always want to use one of the other two angles. In this case, I want to use the 5 degrees because that is the only angle measurement that I'm given. I don't know how much the other one, I mean, I could find it, but since they gave me the 5, I'm just going to go ahead and use that. So if I'm looking at the 5 degrees here, how would the X side relate to that? Would that be opposite, adjacent, or hypotenuse? Good, this would be your opposite side. What would be the 15 then? Good, 15 would be the adjacent side, okay? So I'm going to go ahead and think about opposite over adjacent comes from which one? Sine, cosine, or tangent? Think about SOHCAHTOA up here. Good, it comes from tangent, okay? So I'm going to set this up where I do tangent of my angle, which is 5 degrees. So I'm going to write tan of 5. And then I'm going to set it up. Opposite is my X. and adjacent is my 15. Okay, so I'm going to write it like this. Now I want to solve for x. So we have this fraction over here. How are we going to get the x by itself? How do we get rid of that 15? We're going to multiply both sides by 15. So I'm going to take 15 times here. I'm going to do 15 over here. Okay, so when I do that, they're gone on that right side. And what I have left over here on the left is I've got 15 times this tangent of 5. This is when you're going to want to use a calculator. Okay, so grab your calculator. How you're going to type it in is you're going to type in a 15. And then you're going to want to look for the sine, the cosine, and the tangent button. They should be kind of like in the top-ish, like middle portion of your calculator. So like right above the numbers. There should be 3 buttons. It says sine, cosine, tangent. The abbreviation's there, so hit the tangent button. And then we're going to type in 5. Okay? I would put parentheses around that 5. Make sure that you're closing the parentheses so that you get it done correctly. Or else sometimes if you have to like put stuff in after the sine, cosine, tangent and you don't close your parentheses, it's going to give you the wrong answer. Okay, so hit enter. And you're going to probably get some wild, crazy decimal. Okay, we're going to want to round it here. So let's just go ahead and round it to the nearest tenth. If we do that, I get 1.3 if I round it to the nearest tenth. And then this would be feet. Okay, so that ramp that they're talking about would be about 1.3 feet high from the ground. Questions on that one? Okay, let's come down here to A, B, and C. These are similar idea as what we just did, but they're not giving you a story problem. They're just giving you a triangle with some information. I'm going to actually skip over A, and I want to look at B. We're going to do B together, and I'm going to let you guys do a little bit of practice here with A and with C. Okay, so let's skip to B for right now. 16 degrees is the angle that we're going to use as our reference angle. Okay, because I don't want to use the 90-degree angle box, and I don't need to go through the trouble of finding the other angle in the picture. So using the 16 degrees, what would 8 be considered? Would that be your opposite, adjacent, or your hypotenuse side? Good, that would be opposite. Okay, what would the x be? Good, that would be hypotenuse because it's across from the right angle, which would mean then that this side would be your adjacent side, okay? Because there's nothing over there, I'm not going to use that side. So I have something given to me on the opposite side, and my x is on the hypotenuse side. So what trig function uses opposite and hypotenuse? Sine does, okay? So we're going to do sine, and our angle measurement was 16. So that's going in for like that theta letter that we saw on the other day when we were setting up our trig functions, okay? So sine of 16 equals opposite over hypotenuse. So this would be 8 over x. All right, now this looks a little bit different than the last one because the x is in the denominator this time. But think about what we did up on that ramp problem. How did we get the piece out of the denominator? We multiplied by that 15 up there, right? So if you think about down here, what are you going to multiply by? Okay, so we're going to take this side times x. That's going to cancel it off. And we're going to take this side times x. Okay, good. Now, right now, what I have left is I have x times the sine of 16 is equal to 8. I still, though, want x to be by itself. So x is being multiplied to this quantity sine of 16. That's kind of like a whole big chunk there. So what I'm going to do is divide both sides by the sine of 16. And that's going to help me get my x by itself. So these are gone. So I have x. And then over here, this is the math that we need to do on our calculator. We're going to take 8 divided by sine 16. And again, I would make sure you guys close your parentheses. Just get in the habit of doing that. Okay, hit enter. And I'm getting 29.023642223. Okay, but I'm going to round it here. Now, if I round it to the nearest tenth, it's just 29.0. So I'm just going to write 29. And then my label would be centimeters. And I'm just grabbing that from my triangle. Okay, so what I would like you guys to do now is take a couple minutes, and I want you to do part A and I want you to do part C and see if you can figure out those missing sides. So go ahead and take a couple minutes to do both of those. Okay, I'm going to start going through these here. So let's come back here to letter A. When you're using the 38 degrees, what sides did they give you? Okay, x is your opposite and 12 was your adjacent. So did you guys use sine, cosine, or tangent? Tangent. Okay, so tell me what to write here to set it up. Okay, that looks great. How'd you guys solve for x? Okay, good. You took it times 12. Good. So then if you did the math here, if you took 12 times the tangent of 38 and you rounded it, what'd you guys get? Good. 9.4 centimeters. Very good. Okay. Now help me out. Same thing with letter C. What sides did they give you? Okay, x is adjacent and 18 was hypotenuse. Good. So what function are we using on this one? Cosine. So cosine 55 would be equal to x over 18. And how did you guys solve it? Good, times 18. Okay. And so what'd you guys get here for x? Good, 10.3 centimeters. Very good. All right. Any questions on how to set up those triangles when you're solving for a side?